Hello, statistics student. This video is for chapter 7.2, part 2, is normality assessment. This particular portion is actually not in the OpenStax book, but is a particular topics that needs to be covered for student learning outcome, and it follows very well with the central limit theorem, so I put it over here. If you want reading, it would be in the Triola book. I have a PDF that you can read to look at how the textbook discuss this. So what happened is if you have a sample, we know that a sample size greater than 30 is essential for the sum and also the sample mean to be normally distributed. If they are not normally distributed, then you cannot predict the probability. You do not know how probable a particular value is higher than a threshold or something. So knowing that a particular distribution is normal is quite important. But if you do not have experience with the population, and it's impossible to do a population, you know, um, study to collect all population data to know what is distributed, that's kind of difficult. So we have this dilemma where we want the population to be normal, so we don't have to have a larger sample size to study this particular sample statistics, but at the same time we actually don't know. So what is the tools that we can use to assess that the population is normal is we would just use a sample just like before. So this procedure is a normality assessment procedure is quite important, because if it passed normality assessment, then you can just go with a small sample size to study your sample statistics, the sample mean and also sample sum. So what is this procedure? It involves actually 3 graphs. Of course, if you want to know if the original population is normal, what is better than looking at the samples distribution? And of course, because it is from a sample, it might not reflect it might not be reflecting the population's symmetry and everything, because sample could be like random, right? You could sometimes have more small number and more larger number. So the criteria to conclude normal is much lower. So what we see is if we graph a sample and if the histogram does not depart from a bell shape, then it is okay. But if the histogram departs dramatically from a bell shape, then it is under those situations that we would not say that it's not from a normal distribution. Say, for example, this one. It doesn't look very normal. It seems like it's more, I really can tell, it more concentrate on the on the low side. This is there is not much data in the high side. Well, okay, so it's very hard to say that it's normal from a strictly point of view, right? But it does not deviate from a bell shape. So you see some low number, some high number, and a peak. If you see a distribution like that, you can say that it doesn't depart dramatically from a bell shape. So this would pass. Okay. The second thing is outliers. So because normal distribution do not have outliers, and it's very low chance to get data at the 2 or 3 standard deviation away. So in your sample, you should not have more than 1 outlier. So if there's exceedingly lots of outliers that point to the fact that it's not normal. Okay, so look at the number of outliers. The third thing is a new plot called normal quantile plot. So because you say, what is normal quantile plot? Normal quantile plot is a plot where you plot the x is the x value, the y is a z-score. Remember, z-score is the number of standard deviation away from the mean, right? You get the x, you minus the mu, and over sigma. So if it is not far away, and you can see that this is linear, right? So you would just put them in plot this, and then it's maybe a scatter plot or something. So if they are along a line, if they're close to a straight line because of the linear relationship, then then we say it could be normal. But if the point have some systematic pattern that is not a straight line like this kind, I didn't have an example on those. Like they are far away, they have some wavy pattern, or so although they are close to a line, but there's some wavy pattern or pattern that is systematic, then we say they are not normal distribution. The plot is called normal quantile plot. So how do you plot this point? These normal quantile plot? You can use StatDis. So let's go over to the StatDis. Yeah, you choose StatDis. You put your data into here, and you say explore data. Underneath explore data, there is a normal quantile plot. So that's where you plot the data and you look at the outcome. If it's close to a line, then you say, yes, the sample is from a normal. So this one is good, right? This is close to a straight line. And I think in the statistics normal quantile plot, they actually do a trend line over there. So these are the steps. So let's do an example to illustrate all the steps. So we have a sample, and we don't know if it might have come from a population that is normal because I have only small samples. And if it is normal, then I can use central limit theorem. So let's do the test. So I put it in here. It's 1, 2, 3, 4, 5, 6, 7, 8, 9. So I have 9 data. I put in here, and then I do data normality assessment. Is in 1. You do evaluate. So this the output that we look at. We haven't looked at these tests, and it's outside of our study. So all we need to look at is number of outliers is 0 and 0. The histogram is histogram is really symmetrical, so it is quite promising. And also look at the normal quantile plot. This is the normal quantile plot. It is close to a straight line. All the points are close to the straight line. So C score X value. So we can see that I cut and paste them here. See, this is it. And so the final conclusion is the sample are from a population that is normal. What is the reason? You might want to explain the reason. The reason is 1, there's no outliers. 2, histograms show a normal distribution from the sample. Does not depart from being a bell shape. Is very bell shape. And 3 is quantile plot is with points. Quantile sometimes it's called probability plot. Sometimes it's called normal quantile plot. Has points close to a straight line. So these are the 3 explanations that you should give, or the 3 area that you should check that confirm that this sample are from a population that is normal. So although I have a low sample size, I can still use central limit theorem.